Okay, so in the first question we've been asked to find the inverse of p. That's what p to the minus 1 means. Now, if we look at our formula sheet, we can see that first thing you need to do is work out the determinant of A, which is the product of the lead diagonal, take away the product of the other diagonal. So here we're going to work out the determinant of P. So the determinant of P is 4 times minus 2, take away 1 times 0, plus minus 12. And then if we have a look again at our formula sheet, we can see to get the inverse of a matrix, you multiply by 1 over the determinant, and then you swap the elements on the lead diagonal and you change the sign on the other diagonal. So in this case we're going to have the inverse of P is 1 over minus 12, which is minus a 12th. Upon swapping gives us minus 3 and 4 down here, and changing the sign gives us minus 1 and 0. Now if you want, you can always check if you've got this right or not, if you've got time. So what you can do is you multiply the inverse, so in this case by the vector. So in this case we're going to multiply it by 4, 1, not minus 3. Okay, so that becomes minus 1 over 12. Minus 3 by 4 is minus 12, and nothing's minus 12. Minus 3 by 1 is minus 3. Minus 1 by minus 3 is plus 3. Add them together, you get nothing. Nothing times 4 plus nothing times 4 is nothing. And last but not least, nothing times 1 and minus 12 is minus 12. So multiplying through we get 1 naught, naught 1, which is the identity matrix, which is what we were looking for. So as I say, this is just a check that you've got the inverse correct. You don't have to do it, it just lets you know that you've got the answer right. Now move on to part 2. Find x when px equals q. Now the way to solve this type of equation is multiply both sides of the equation by the inverse of p. So got to be careful, so we're going to multiply both sides by the inverse of p. Now it has to go in front on both sides. Now when we multiply the inverse of p by p, as our check shows, that becomes the identity matrix. And the unique property of the identity matrix is multiplying by it does not change a matrix. So what we now know is that x is actually equal to the product of the inverse of p times q. So we can now do that because we have both of those from our work above. Okay, so x is equal to the inverse of p minus a 12th times q, which is 8 minus 5. Now whenever you do any matrix multiplication, you should always write down the shape of the matrices. So in this case 2 rows by 2 columns, 2 rows by 1 column. The reason you do this is you've got to make sure that those middle values in the shape match. So in this case to do, so we can do the multiplication. And then the other reason is the outside two numbers will always give the shape of the answer, a 2 by 1 matrix. So we know when we multiply this out, we're going to get 2 rows of 1 column. So our answer is going to look like this. So multiplying out, we get minus 1/12, we'll leave that there. Then multiplying first row by first column, minus 24 plus 5 is minus 19. Silly me, I've miswritten that, that should have been 9. Okay, so minus 27 plus 5 is minus 22. And minus 20. Okay, so x turns out to be 11 over 6 and 10 over 6.